This is lesson 9-8, compound events. Reginald has 3 state quarters, one from Colorado, one from Montana, and one from Washington. If Reginald picks one quarter without looking, what is the probability that it's from Colorado? Well, there's one successful outcome out of 3 total outcomes. Suppose he tosses the coin. What is the probability it lands heads up? 1 positive outcome out of 2 possible. Make a tree diagram to find the probability of choosing a Colorado quarter that lands heads up. Well, let's go. We'll go Colorado, heads, tails. Montana, heads, tails. And Washington, heads, tails. The outcome we want is Colorado heads up. So it's this one right here out of a total of 6. 1 positive outcome out of 6. How are the answers to exercise 1, 2, and 3 related? Well, if you look at it, these 2 answers, when you multiply them together, you get this answer. In the example above, choosing a quarter and tossing a heads is a compound event. A compound event consists of 2 or more simple events. Since choosing a quarter does not affect tossing heads, the 2 events are called independent events. The outcome of one event does not affect the outcome of the other. A coin is tossed and the spinner shown is spun. Find the probability of tossing heads and spinning a consonant. Well, let's see. The A is a vowel. Here's heads and a consonant. Here's heads and a consonant. Those are our only 2 heads. We have 2 out of 6, which simplifies to 1/3. We can also write that, if we choose, as 33%, about 33%. It's actually 33 1/3%. But it clearly says about here. Check your progress. A number cube is rolled and the spinner in example 1 is spun. Find each probability. Well, the probability of tossing a 4 is 1 in 6. We have 2 consonants out of 3 here, so that probability is 2 out of 3. We can simplify here and here before we multiply. So the probability of tossing a 4 and spinning a consonant is 1 in 9. In example B, an odd number on a number cube would be 1, 3, and 5. So that's 3 out of 6. 3 favorable out of 6 total. And we have 1B out of 3 letters on the spinner. We simplify here and here before we multiply. And the probability of those 2 events occurring is 1 in 6. As it says here, the probability in example 1 can also be found by multiplying the probabilities of each example. 1/2 is the probability of the heads. 1/3 is the probability of the consonants. So the probability of heads in a consonant is 1 in 6. The key concept, the probability of independent events. The probability of 2 independent events can be found by multiplying the probability of the first event by the probability of the second event. Brianna is buying a new outfit. She is choosing among 2 red, 1 purple, 3 pink, 4 yellow tops. For pants, she is choosing between jeans or capris. If Brianna chooses a top and capris at random, find the probability that she chooses a yellow top and jeans. While we have 4 yellow tops out of 10 total, we have 1 capri out of the 2 total. So we can multiply those 2 events together. We simplify the 2 and the 4 by multiplying by the common factor of 2. We multiply those together. We get 2 over 5, which again can simplify, or 2 over 10, which simplifies to 1 in 10. So the probability of picking a yellow top and jeans is 20%, or 1 in 5. If khakis and shorts are added to Brianna's pant choice, find the probability that she chooses a red top and capris. Well, there's 2 red tops out of the 10 instead of 4 like there was with the yellow. Now instead of one choice out of 2 for the pants, it's 1 out of 4. So we can simplify here and here. And then we multiply those two numbers together, and we have a probability of 1 in 20. Or about 5%. If the outcome of one event affects the outcome of a second event, the events are called dependent events. Just as in independent events, the probability of dependent events can be found by multiplying the probabilities of each event. However, now the probability of the second event depends on the fact that the first event has already occurred. If two events A and B are dependent, then the probability of both events occurring is the probability of A and the probability of B after A occurs. Sounds complicated, really isn't. In the example, there are 2 red, 5 green, and 8 yellow marbles in a jar. Martina randomly selects 2 marbles without replacing the first. What is the probability that she selects 2 green marbles? Since the first marble is not replaced, the first event affects the second event. These are dependent events. So the first marble is green, there's 5 out of 15. Then because that event affects the second event, now we have only 4 out of 14 probability of drawing a green marble in the second trial. So it's 5 over 15 times 4 over 14. We simplify both directions and we get an answer of 2 over 21, which is about 9.5%. Not good. Check your progress. There are 4 blueberry, 6 raisin, and 2 plain bagels in a bag. Javier randomly selects 2 bagels without replacing the first. Find the probability that he selects a raisin bagel and then a plain bagel. Well, 6 out of 12 are raisin, but because the occurrence of the first event affects the second event, there are now only 11 left. So the probability of selecting a second one is 5 over 11. This fraction you can see clearly simplifies to 1/2, giving us then a probability of 5 over 11. Or 5 over 22, pardon me, 5 over 22. Sometimes 2 events cannot happen at the same time. For example, when a coin is tossed, the outcome of heads cannot happen at the same time as tails. Either heads or tails will turn up. Tossing heads and tossing tails are examples of disjoint events, or events that cannot happen at the same time. Disjoint events are also called mutually exclusive events. Number cube is rolled. What is the probability of rolling an odd number or a 6? Well, there's 3 odd numbers and 1 6, so that's 4 out of 6, which simplifies to 2 and 3. 26 cards are labeled, each with a letter of the alphabet and placed in a box. A single card is randomly selected. What is the probability that the card selected will be labeled with the letter M or the letter T? Well, the probability of the first event is 1 out of 26. The probability of the second event is 1 out of 26. We add the 2 together, we get 2 out of 26, which is 1 in 13. Notice that the probability for example 4 can also be found by adding the probabilities of each event, which is what we did here. Check for understanding. A number cube is rolled and the spinner is spun. Find each probability. The probability in number 1 of a 5 and an E. Well, there's 1 5 out of 6 possibilities. There's only one E on the spinner, so that's 1 and 5. Independent events, then we would multiply together and we get 1 over 30. Example 2. We want a 2 and a vowel. A 2 is, the probability is 1 over 6. In this case, we have 2 vowels out of 5. We simplify here and here, and our probability is 1 in 15. Example 3. We want a 3 and a consonant. Again, the probability of the 3 is 1 in 6. So we have 3 consonants on our spinner, which is 3 and 5. Simplify here and here. Gives us a probability of 1 in 10. Number 4. A factor of 6 and D, there are 4 factors of 6. 1, 2, factors of 2. Yeah, factors of 6. 1, 2, 3, and 6. So that's 4 and 6. And a number less than 3, a factor of 6 and a D, pardon me, is 1 in 5. So this simplifies to 2/3, which gives us a probability of 2 in 15. Number 5. Loretta has 2 pair of black pants, 3 pair of blue pants, and 1 pair of tan pants. She also has 4 white and 2 red shirts. If Loretta chooses a pair of pants and a shirt at random, what is the probability that she will choose a pair of black pants and a white shirt? Well, she has 2 black pants out of 6. She has 4 white shirts out of 6. We multiply those together. Let's simplify here. First, we got 1 here and 3 here and 2 here and 3 here. So our probability is 2 in 9. Example number 6. The jar contains 12 marbles. 4 are red, 3 are white, 5 are blue. A marble is randomly selected, its color is recorded, and then the marble is returned to the jar. The second marble is randomly selected. Find the probability that both marbles selected are blue. So the first event is 5 and 12. It doesn't affect the outcome of the second event, being independent events. So 5 and 12 multiply together, 25 over 144. Problem number 7. The digits 0 through 9 are each written on a slip of paper and placed in a hat. 2 slips of paper are randomly selected without replacing the first. What is the probability that the number 0 is drawn first and then a 7 is drawn? Well, the probability of the 0 would be 1 in 10. Because that number is not replaced, the probability of the 7 would be 1 in 9. So the probability of those two things occurring is 1 in 90. Problem number 8. Number cube is rolled. Find each probability. The probability of a 4 is 1 in 6. The probability of a 5 is 1 in 6. Independent events or disjoint events. Add them together, gives me 2 and 6, which simplifies to 1 and 3. This is example A. Example B. 3 are an even number. There's 1, 3. There's 2, 4, 6, which is 3 out of 6 even numbers, which gives me 4 and 6, which simplifies to 2 and 3. Example C. We want, or actually this is 8, this is 9, sorry. This is 10. C. 1 or a multiple of 2. There's a 1 possibility in 6 that we'll get a 1. A multiple of 2 would be 2, 4, and 6, so that's 3 and 6. Add them together. Gives me 4 and 6, which again simplifies to 2/3. And number 11, our last example. We want a 6. There's 1 and 6, or a number less than 3. That would be 1 and 2. So that's 2 and 6. Add them together gives me 3 and 6, which simplifies to 1/2. 1, 2, 3, 4 vocabulary terms: compound event, independent events, dependent events, and disjoint events. Students should memorize these vocabulary terms, put them in their notable. They'll be on the Chapter 9 vocabulary test. At this point, you should stop the video, log into NICU at www.nicu.net, log in with your student number, and use the password, which is your student number and your entire last name, and take lesson quiz 9-8. Thanks for watching.